Alright guys, I'm going to show you a video of the quadratic formula. Okay, now I'm going to go through a couple of examples in this video. I'm going to assume that you've seen the quadratic formula before. I'm not going to teach you how to get it, where it comes from, or any of the necessary nuances, but we are going to use the quadratic formula to solve an equation. We're also going to tie in the idea of the discriminant. Okay, so here we go. We know that in order for the quadratic formula to work, that it needs to be in standard form. Y equals ax squared plus bx plus c. This is in that format. We can see that a being the number in front of the x squared, well, we don't see one there, which means it has to be 1. It can't be 0, because 0x squared would mean that we don't have the x squared there. So therefore a has to be 1. B is the number in front of the x by itself, which is 2. And c is the number that is the constant at the end, so 5. So now we're going to go straight into the quadratic formula. The quadratic formula is x equals negative b plus or minus square root b squared minus 4ac all over 2a. Now from there, you can go ahead and put the numbers in. So anytime I substitute, I remember to put it in parentheses. So I go negative b, which is 2, plus or minus the square root of b squared minus 4ac, so 2 squared minus 4 times a times c. Now these values are coming from these over here, all over 2 times a. Now, what I generally say is let's worry about the stuff inside first. Now the reason we're worrying about the stuff inside first, and you don't even have to write out the whole thing, you could just start with the discriminant if you wanted. But this is what's called the discriminant. And we're going to do that first because that sometimes gives us information about the questions. So I'm going to ignore everything else just for a minute. I'm going to do the square root of 2 squared, which is 4, minus, and so I go 4 times 1, which is 4, times 5, which is 20. And so you'll notice that here I got 4 minus 20. Now if I were to rewrite everything else, and 2 times 1 being 2, then what I would see is that I now have negative 2 plus or minus the square root of negative 16. Now we know that the square root of negative 16 is not a real number, and by that we mean that there is an answer, it's imaginary. Yes, imaginary numbers are the ones that aren't real. Congratulations, good idea. Anyway, so this does not have any real roots. So this is what's called the discriminant. It's the discriminant because it discriminates whether there are real roots or not. So because the discriminant is negative, that means that there are no real roots, or no real solutions, or no real x-intercepts, okay? That means that this is some type of graph that does not cross the x-axis. All right, let's go on. Let's look at another one. Example number 2. Again, we need to make sure that it's in y equals ax squared plus bx plus c, standard form. Now when we look at this, we note that it's not in that form. So what we need to do is we need to get it in that form. So I need to get rid of this x plus 2 in the parentheses squared. How do I do that? No, don't you dare distribute that squared. You distribute that squared, I'm going to come over there and slap you. I don't care what country you're in. You do not distribute that squared, because there is a plus there, and we know that we never, ever distribute the exponent when there is a plus or minus. That only works, in fact, it only works for multiplication and division, so don't you dare. What we need to do is say, well, squared means I'm going to multiply it by itself. And so that's what I'm going to do. Now I know how to do that because I just FOIL. So I go x times x, which is x squared. I go x times 2, which is plus 2x. 2 times x, which is another 2x, and 2 times 2, which is 4. And I combine the like terms, giving me x squared plus 4x plus 4. And so now it's in the right format. So I can say a again equals 1, b is 4, that's the number in front of the x, and c is the number at the end, which is also 4. So from here, I can now go ahead and use the quadratic formula. So I can go x equals negative b plus or minus square root b squared minus 4ac all over 2a. There we go. So now that I have that, I can go ahead and put in the numbers. So I'm going to go x equals negative b, which is 4, plus or minus the square root of b squared minus 4 times a times c. And note that every single letter I'm putting in parentheses because that's the safest way to do it, all over 2a. Now again, I'm going to focus on the inside of the square root. If I do that, 4 squared is 16 minus, let's see, negative 4 times 1 is negative 4 times 4 is negative 16. So minus 16, and 16 minus 16 is 0. All right? So because this is the discriminant, the thing inside the square root, so I was just working on this part right here. I didn't worry about the square root yet. So because this ended up giving me 0, that means that I'm going to have 1 real root because the discriminant equals 0. So let's go ahead and do that. So we're going to go back to our work here. We've got x equals, and then that'll be a negative 4 plus or minus the square root of 0 all over 2 times 1, which is 2. So that then, of course, x equals square root of 0 is 0, so negative 4 plus 0 over 2, and x equals negative 4 minus 0 over 2. And you'll notice that negative 4 plus 0 is negative 4 divided by 2 is negative 2. And negative 4 minus 0 is also negative 4 divided by 2, which is also negative 2. So the x equals negative 2, therefore, is the only place where I get an x-intercept. So an x-intercept, or a solution of negative 2 comma 0. All right, there we go. We got 2 under our belt. Let's look at one more. Whoa, too far. There we go. So now we're ready for one last question. Again, we want to make sure that it's in y equals ax squared plus bx plus c. Is it? Why, yes. No, it's f. Yeah, that's fine. F of x, remember, f of x is the same thing as y. So that's okay. Y equals 2x squared minus 7x plus 2. If I'm using the quadratic formula, that's because I'm trying to find the x-intercept. If I want to find the x-intercept, that makes y 0. And so now I can go a equals 2, b equals negative 7, and c equals 2. So I go x equals negative b plus or minus square root b squared minus 4ac all over 2a. You should be writing this every time. Now, I know that it saves time and it's less work if you don't, but I guarantee you that if you write this every single time for the next 2 weeks, you're going to have this memorized, and it's not going to be an issue because you will have written it over and over and over again. Do it on your math paper. Do it on your history paper. Do it on your science paper. Your science teachers will be glad that you're doing quadratic formula. Your English teachers will probably get mad, but who cares what they think anyway? So here we go. We go x equals negative b. Now b is negative 7, so negative 7 plus or minus the square root of negative 7 squared in parentheses minus 4 times a times c all over 2 times a. So from there, we've got x equals. Now I'm going to go ahead and do the same thing as before. I'm going to worry about the discriminant first. Negative 7 squared is negative 7 times negative 7, which is 49. And then negative 4 times 2 is negative 8 times 2 is negative 16, so minus 16. 49 minus 16 is 33. Okay, now that is a positive number, which means I'm going to have 2 real roots, right? We looked at the 2 examples previous. In the first one, I got a negative discriminant. That meant no real roots. In this one, I got a discriminant of 0. That meant there was 1 real root because I was adding and subtracting 0. In this one, I've got a positive number, which means I'm going to have a discriminant is positive, therefore 2 real roots. Now, for the time being, you're going to be allowed to just rewrite this as negative 7, which is positive 7, plus or minus the square root of, and we worked out all that stuff already, so 33 over 2 times 2, which is 4. And so from here, it's going to be x equals 7 plus the square root of 33 divided by 4, and x equals 7 minus the square root of 33 over 4. If it's on a non-calculator section, you can just leave it like that. If you've got your calculator, you may as well pull it up, and we'll go 7 plus the square root. Oh, nope, square root, please. Go back. No, not that far back. Delete. No, delete, delete. Okay, sorry, this is not my happy day. So there we go. Square root of 33. So 7 plus the square root of 33, and then divide that by 4, which is x equals 3.186, was it? Yeah, 186. Okay, and then we can do the same thing here. We'll go 7 minus the square root of 33, and then divide it by 4. So I get 0.314. And so those are my two roots or solutions or x-intercepts. Now just a note on the calculator, since I've already gone way over 5 minutes. So since we have that, we can, if we're doing the calculator, I just want to point out you can't do this all at the same time. For example, you can't go 7 minus root 33 and then go divided by 4. You cannot do that because that is going to do, your calculator knows PEMDAS, it's going to do the root 33 divided by 4 first, and then it will do the subtraction. Here, watch. Beep. That's not the same thing as 0.314. Okay, just in case you didn't know, those two are not the same thing. So if you want to do this all in one step, what you need to do is you need to put the 7 minus 33 in parentheses. Remember, and we've talked about that in class, how we said if something's on the top of a fraction, that it's kind of like it's in its own little world up there. You need to put it in parentheses. And if you do that, then you'll make sure that the calculator will do it correctly, which you'll notice now I get the same thing as I did that first time, the 0.314. All right, so there you go. I hope that's enough. There's a couple of examples for you dealing with the quadratic formula and the discriminant. Ciao.